So what we're going to finish up with here is solving some equations using these logs and exponents kind of interchangeably. So if we have an equation like 16, log of 7x plus 6 equals 3, if we want to solve this for x, we're taking the log of this thing. So it's not like we can subtract 6 or divide by 7. We have to get rid of the log. And the way we do that is by writing it as an exponent. So this is a common log. It's base 10. Hang on, I got to get a pencil here. So base 10. So we're going to rewrite this. 10 to the third power equals that. 10 to the third power equals that. And now this is a super easy problem. 10 to the third power is 1,000. We're going to subtract 6 from both sides and then divide by 7, which does go in evenly, believe it or not. There it is. So now let's try it with number 17. Natural log of 3x minus 1 equals 2. Again, we want the natural log to go away. So the way we do that is we rewrite it as an exponent. Natural log is base e. So we're going to rewrite this as e squared equals that. Now, e squared, you can do that in your calculator. It's 7.389. Just leave it in your calculator as we continue through this problem. That way we don't have rounding error. I'm going to add 1 to both sides, and then we'll divide by 3. And again, if you just leave that crazy decimal in your calculator, you won't have rounding errors. And there's that for x. All right, number 18. Again, we have log of x minus 3 equals negative 1. We want to get rid of that log, so we're going to rewrite it as an exponent. This is a common log, so base 10. So 10 to the negative 1 power equals x minus 3. Now, the way we get rid of negative exponents is we put them underneath. So this is 1/10. And then I'm just going to add 3 to both sides. So my answer is 3 and 1/10, or 3.1 if you prefer. Okay, so those were all ones where I had logarithms in the problem, and we solved them by writing them as exponents. We can do this the other way. For example, we have 10 to the t plus 1 equals 50. I need to get the t plus 1. I need to get the t out of the exponent. So what we'll do is we'll write it as a logarithm. So this is log base 10, which we don't actually have to write. The exponent goes over here, and then 50. Now, since this is a common log, we can do this in the calculator. The log of 50, when you put it in the calculator, is 1.69897. And then all I have to do is subtract 1. So before, we had a lot of problems like this before that we were just like guessing and checking on. Now we actually have a way to get the t out of the exponent. All right, let's check out number 20. Before we do anything with this, we need to divide both sides by 1.5. We want that e by itself. Okay, so we get e to the t equals 18. Now, I don't want that t in the exponent, so I'm going to write this in logarithmic form. So it's base e, so that's natural log. Exponent goes over here, and 18 goes here. So t is just the natural log of 18, and you just type that into your calculator, and you get 2.89. All right, one more like this. Again, we're going to get the e by itself before we start doing anything fancy. So e to the t equals 14.036. I want the t out of the exponent, so I'm going to rewrite it as a logarithm. It's base e, so it's natural log. Exponent goes on the other side. 14.036 goes here. And then to solve for t, all you have to do is type in your calculator the natural log of 14.036, and we get 2.64.